Hello guys, in this video I will try to explain Newton's second law of motion. Guys, as far as Newton's first law of motion, none of the students perhaps have any problem in understanding the Newton's first law of motion. Newton's first law of motion states that when a body uh, is in rest, it wants to be in rest, and a body is in motion, it wants to be in motion. It is nothing but the law of inertia, the tendency of a body to regain its original state of rest or in the uniform motion, unless and until any external force is applied on it. So, but according to Newton's third law of motion, to every action there is equal and opposite reaction, but acts in different bodies. So, in Newton's first law of motion and Newton's second law of motion is more or less subjectively, and students have rather any problems on it. Students has problem to understand Newton's second law of motion, and students has also problem in solving the numericals of it and solving the numericals of third law of motion also. So first we will derive the formula for Newton's second law of motion. Derivation of the formula for Newton's second law of motion. See, the Newton's second law of motion states that force is directly proportional to the rate of change of momentum. Rate of change of momentum. So guys, to understand the Newton's second law of motion, we will have to understand what is rate of change of momentum. But before it, directly proportional to force is directly proportional to the rate of change of momentum, means directly proportional. This is the sign of directly proportional. That means when force increase, the rate of change of momentum increase, or the rate of change of momentum increase, then force is increased. So vice versa. So directly proportional means if one quantity here on the left hand side increases, the other quantity on the right hand side also increases, and vice versa. So first we will try to understand what is rate of change of momentum. To understand the rate of change of momentum, we should know what is momentum. Momentum is nothing but mass into velocity is the momentum. And momentum is denoted by this type of P is equal to M into V. So the SI unit of momentum is equal to, for mass it is kg, into velocity meter per second. So this is the SI unit of momentum. This is an important point in this Newton's second law of motion. Now we'll come to the change in first we'll understand what is change in momentum. So change in momentum. Let us understand change in momentum. Here is a body with mass m and initial velocity u. Mass is equal to m, initial velocity is equal to u. And suppose it is moving, and here the same body, mass is equal to m, and velocity, final velocity, is equal to v. So therefore change in momentum will be equal to initial momentum minus final momentum. Now initial momentum will be m into u as per this formula. Momentum is equal to mass into velocity. So mass into initial velocity. And here change in momentum will be final velocity, please correct it, final velocity, final momentum, minus initial momentum. Now final momentum. So momentum is equal to mass into velocity. Here mass is m and velocity is v. So final velocity is mv. Now minus initial velocity. Initial velocity is mu. So we get m into v minus u. Therefore, rate of change of momentum is equal to m v minus u by t. Recall why I have put t here, because I have kept rate here. Change in momentum is here, but rate, when we apply rate, it will, in denominator it will come t. Recall the definition of acceleration. Acceleration is equal to rate of change of velocity. So we used to write like this upon t. So when rate is used, in physics we will put t in the denominator. So we have obtained derived a formula for rate of change of momentum. To the rate of change of momentum this implies force is proportional to m v minus u upon t, as I have derived just before. Now, when it is in physics, when they one quantity to other, in order to omit the proportionality, we used to take some constant here. This implies force is equal to, now proportional is changed in is equal to, therefore we will have to put constant here, k into m v minus u by t. Now k is equal to 1. Now k is equal to 1 because 1 Newton is equal to 1 kg of mass into 1 meter per second. Therefore, k is equal to 1. So we get from here F is equal to m into v minus u by t. Now we know, we have read uh, earlier in the earlier chapter we had studied that acceleration is equal to v minus u upon t. So here this can be written as a. This implies force is equal to m into a. Yani where f is force, m is mass, a is acceleration. F is equal to force, m is equal to mass of the body, a is equal to acceleration of the body. Therefore, it is kg, and for acceleration it is meter per second square. Recall the unit of mass and unit of acceleration. So the unit of force is kg into meter per second square, and this quantity kg into meter per second square is written as Newton, in the name of the scientist Newton. So the SI unit of force is Newton, denoted by capital N. Now, all of the above equations, this equation, the equation 1 and equation 2, are helpful in solving the numericals. For equation 1, when mass, initial velocity, final velocity and time is given, we use to calculate force, or any of the above. From this, if the quantities are given and we have to calculate the other quantities, we use this formula. Similarly, force is equal to mass into acceleration, where mass is given or any of these three quantity, two are given, then third can be obtained by using the simple equation. So sometimes in the question distance is given in numericals. Distance s, you know the distance is denoted by s, is given. In such type of question, students get confused that we had formula 1 and formula 2. Now s is given, then how we can solve? Then in that case we will apply the formula, apply the formula we recall the equations of motion. V square is equal to u square plus 2as, and from by the help of simple equation, first we will calculate acceleration where v, u and s is given. Then we will derive the formula, then we will apply equation 1 or equation 2 as per the given questions. Thank you for it, and in the next video I will solve few of the numericals based on Newton's second law of motion. Thank you.